Biology students, today's lesson is going to focus on control versus experimental groups. It's a very similar flow to the independent versus dependent variable from last week. So like usual, go into your class module, click on the first link. It'll take you to a series of notes. Again, the focus is experimental versus control. Just to highlight this, experiment means you must change something that you're going to test the results of in an experiment. Control means everything but the one thing you decided to change will be kept underneath normal conditions. As you can see, there's a handful of slides here for you to take a look at. This will be critical for your final project in this unit. So I want to just touch on a few highlights. Independent means you change it, right? So experimental and an independent are very similar. Dependent, it changes. Last week, or last lesson rather, we talked about you measure dependent. Experimental, you only change one. Supercritical and control, you change none. That means in an experiment, everything stays the same except for the change one in the experiment that you want to test. Okay? And so with that said, I will take you to your assignment, which is hopefully loading here. Maybe I have to refresh. All right, so it takes you to a CAMI assignment like last time. Again, it reviews some of the vocab words up top, independent versus dependent, and then the new stuff, control versus experimental. Just as before, you read the problem. So Stella thinks people exposed to UV light are more likely to get skin cancer. So she designed an experiment where sample A consists of people exposed to light and sample B was not. Okay, so the control group in this situation would be the group that was kept the same, which would be not exposed to UV light. The experimental group, of course, would be the other group, whereas you're now being exposed to UV light, which is not under normal circumstances. Independent variable, in this case, what are you going to look for? Are you going to get increased skin cancer? And so by being underneath UV light, that's independent, and skin cancer is the dependent variable. So skin cancer depends on UV light in terms of causing cancer. So you just go through and use text boxes for that. And I just want to preview how this looks in a lab setting. This will actually be an intro to what your summative will be like in a few days. All right, so in this particular thing, we notice we have a few variables. Light, which we have 3 light bulbs on. We have water set at a certain amount, 50 milliliters, and we have the same temperature. So what are we going to test in terms of getting the most number of sprouts? So we're trying to figure out what sample here will give you the most number of sprouts. So the thing we're changing, meaning the experimental variable, is the seed type. So we have 3 seeds, A, B, C, underneath exactly similar environmental conditions. So I go ahead and drop seed A in there, I drop seed B in here, and I drop seed C in there, and I click timer, and the time ticks, tick-tock, tick-tock. They're each getting the same number of water amounts, the same amount of sunlight, which in this case is light bulbs, and the same amount of heat, which would be equivalent to the sun. And if we were to go through and count the sprouts, they did the counting for you, we notice here seed A is the one that gives most sprouts with identical environmental conditions. As we'll see in the summative, you have the option to change the water amount, change the amount of light, change the type of seed, or keep the seed the same, change the temperature, or keep the temperature the same. So with that said as an intro, you should be all set for your asynchronous assignment. And you will see this simulation in a couple of days if all goes well.